Hello, my friend. This is Amit Sharma, and today I have started a new lecture series, basically to strengthen the fund of the electrical elements and electrical circuits. So, my friend, let me ask you one question. That as you have must have seen this famous picture of Nikola Tesla sitting beside a voltage, a very high voltage source, which are like transferring their charge into the air. And Nikola Tesla is like calmly reading his books, and beside sitting with this giant voltage source. What do you think about it? In this universe or in this our world, everything is made up of the atoms. So atom atom have nucleus which are in the center, and around them there are the cells. In cells, electrons revolve, as you have must have like learned about this in your school days. And the nucleus here, proton and neutron reside. You got my point? So point is that, my friend, that electrons have charge, have charge, and charge are measured in coulomb. Like SI unit of charge is coulomb, So, my friend, one like if you take one atom, simply one atom, you will find that around that atom there are a certain type of elliptical paths are formed and circular paths are being formed, on which electrons are revolving. That is the basic laws of nature, that in the center this nucleus will reside, where you can see in the green color there is proton, and in the red color you can say maroon color it is neutron. And around this nucleus you can see in these cells electrons are situated, and these electrons move around the nucleus. So, my friend, one electrons carry 1.6 cross 10 to the power minus 19 coulomb charge. But, but electrons are negatively charged. It carries, its nature of charge is negative. But proton, in this case, proton, which also carry the charge, but in the positive direction. You can say it is positively charged. One proton carry charge at equal to the one electron carry charge, like plus 1.6 cross 10 to the power minus 19 coulomb. So, my friend, this is the like clickbait you can see here. So, as I have described right now, that atoms have protons, neutrons, and surrounded by electrons. So, as you have must have experienced this day-to-day interesting phenomena, like when basically in the winter season, you have must have experienced this phenomena when you take out your woolen cloths, and you must have heard that some like chit chit sound, that type of sounds. So that is the charge sound. Basically, what happened there, that when your body and the woolen cloths get rubbed, then charge get transferred between the woolen cloths and your body. So here is the catch. There is a law called charge conservation law. According to charge conservation law, it is pointed out that charge can neither be created nor be destroyed. It can only be transferred. We cannot create the charge, we cannot destroy the charge. Charge can only be created. A charge can only be transferred. As you must have seen in the during the rainy season, you must have experienced this, that you must have experienced this lightning effect. Okay. So what is this? This is basically the transferring of charge which formed in the upper part of a sky, which get transferred to the earth, or we can say ground. So this is basically the charge transfer. Lighting is nothing, just a charge transfer. So my friend, I now we got to understand what is charge and how it got and get transferred, and what is charge. It is basically an electron which carry the charges. So my friend, now we will learn about what is the current. Current. What is current? When anyone say that this wire have current, this conductor have current, what does it mean? It means that it charges are being circulated, or you can say that flow of electrons. Like in any wire, if there is current, we can say that electrons are being flown through that wire or conductor. If there is flow of electrons, then one electron carry 1.6 cross 10 to the power minus 19 coulomb charge. 1.6 cross 10 to the power minus 19 coulomb charge. So charge getting transferred. What is current? It is basically the transfer of charge, or you can say it is basically the flow of electron. Suppose that, my friend, this is the conductor and electrons are getting flown. This is what we say that current are in this wire, or current is present in this conductor. Okay. So, my friend, SI unit of current is measured in ampere. So, and 1 ampere is equal to flow of 1 coulomb of charge per second. Like how much charge getting transferred in unit second. So this gives us the 1 ampere of current. So my friend, according to the mathematical formula, if we calculate the current, it goes like that: di equal to dq by dt. It means that change of the charges or flow of the charges in unit time. So if we want to it is basically a mathematical formula to calculate the current, la to calculate current. And if we want to find the charges, if we are given like current and time, for certain period of time, if this wire have transferred this amount of current and in a certain period of time, then we can find also the charges by this formula of T naught to T I dt. We can find that how much charge have flown through this conductor. So, my friend, there are basically two type of current we study primarily. That is, one is DC current and another one is AC current. DC current means direct current, and AC current means alternating current. So, my friend, basically point is here is mostly clear that if there are some circuit, suppose that this is our circuit. And what is circuit? What is the electrical circuit? Basically, electrical circuit is the connection of the electrical elements. These are the electrical elements like resistor, like an battery, or we can say the voltage source or current source. So it is basically a connection of the electrical elements. So you can write here that electrical circuit means the connection of electrical elements. So, my friend, as I have told you that there are two type of basically currents, that is DC and another one is AC current. So, in DC and AC current, there are one law which are primarily used in the electrical circuit, and you can say it is the basic law of electrical circuit. That law is called as the Ohm's law. This law is Ohm's law. According to this law, current in any circuit, current in any circuit is proportional to the voltage. Suppose that if you have this circuit, in this circuit you can see there is our voltage source, another one is our like resistance, or you can say this is our load, and there are some currents are getting flown, and you can see this circuit is being completed or it is in a loop. So when we say that in this circuit current are being flown, it means that electrons are getting transferred through this, like you can say through this direction or through this hole, like channel which are being formed. So basically according to Ohm's law, current is directly proportional to voltage. It will be universal truth for any of the circuit, whether it is the DC current circuit or AC current circuit. So my friend, as you must have seen this, like current are getting flown. So there is another term come into the picture, which is called as the resistance. What is resistance? Resistance is basically nothing but it is a property of the conductor. It is basically property of the conductor, my friend. So, like according to Ohm's law, when V equal to IR, according to the Ohm's law, this come into the existence. This formula comes into the existence. Uh, when we say when we say according to Ohm's law, V equal to IR, it means that this R is constant because it is the property it is the property of conductor, nothing but we will discuss later, but it here is the catch. Resistance can be changed if temperature get changed. So basically in this meanwhile, what happened that when temperature get like increased, if it is for the only conductor, if temperature get increased, then the resistance will be get increased as well. If temperature will decrease, then resistance will also decrease. For only it is only for the metallic conductor. Metallic conductor. Okay, my friend. So according to Ohm's law, I equal to V by R. So you can see here that current is inversely proportional to resistance. Current is inversely proportional to resistance. It means that if current will increase, then resistance must be down. Suppose that in any circuit, if we take higher resistance like 5 ohm, then current flowing through will be lesser than if we take another electrical circuit of same voltage source, and here resistance is 2 ohm, then current here will flow more rather than in this circuit that current is getting like decreased. So V equal to IR, as you can find here, current is inversely proportional to resistance, but current is directly proportional to voltage.